Good morning to all. Today I am going to tell about Wien-Bridge oscillator, and this is the circuit of Wien-Bridge oscillator, and it is usually preferred for low frequency applications used to generate low frequencies and uses both positive and negative feedbacks, and it is a bridge circuit product of opposite impedances are equal at the balanced condition, and Z1 Z4 is equals to Z2 Z3. Z1 Z4 is equals to Z2 Z3. Z2 is equals to R2 parallel to XC2. R2 by J omega C2 by R2 plus 1 by J omega C2 is equals to R2 by J omega C2 by J omega R2 C2 plus 1 by J omega C2 is equals to R2 by 1 plus J omega R2 C2. Z2 is equals to R2 by 1 plus J omega R2 C2. Z1 is equals to R1 plus 1 by J omega C1. Z1, substitute Z1 equation in Z1 and Z2 equation in Z2. Z1 is equals to Z1 Z4 is equals to Z2 Z3. Z2 is equals to R2 parallel to XC2 and R2 by J omega C2 by R2 plus 1 by J omega C2 is equals to R2 by J omega C2 by J omega R2 C2 plus 1 by J omega C2 is equals to R2 by 1 plus J omega R2 C2. Z2 is equals to R2 by 1 plus J omega R2 C2, and it is parallel when it is parallelly connected, and Z1 is equals to R1 plus 1 by J omega C1 when the Wien-Bridge circuit is connected in series. Z1 Z4 is equals to Z2 Z3. R1 plus 1 by J omega C1 into R4 is equals to R2 by 1 plus J omega C2 R2 into R3, and R1 R4 plus R4 by J omega C1 is equals to R2 R3 by 1 plus J omega C2 R2. R1 R4 plus R4 by J omega C1 1 plus J omega C2 R2 is equals to R2 R3. R1 R4 plus J omega C2 R1 R4 R4 plus R4 by J omega C1 plus R4 J omega C2 R2 by J omega C1 is equals to R2 R3. R4 R1 plus R2 R4 C2 by C1 plus J of omega R1 R2 R4 C2 minus R4 by omega C1 is equals to R2 R3. Consider imaginary terms is equals to 0. Omega R1 R2 R4 C2 minus R4 by omega C1 is equals to 0. Omega R1 R2 R4 C2 is equals to R4 by omega C1. Omega square C1 C2 R1 R2 is equals to 1. Omega square is equals to, and bring this to this side, 1 by R1 R2 C1 C2. Omega is equals to root square we are taking as root 1 by root of R1 R2 C1 C2, and we know that omega is equals to 2 pi f. 2 pi f is equals to 1 by root of R1 R2 C1 C2, and frequency f is equals to 1 by 2 pi root of R1 R2 C1 C2, and R1 R2 is equals to R and C1 C2 is equals to C. Then the frequency f is equals to 1 by 2 pi R. From Bar-Cosen criterion, A beta is equals to 1. We have to find the gain. Gain formula is equals to Vf of S by V naught of S. Vf of S minus V naught of S into R2 parallel to XC2 by R1 into C1 plus R2 parallel into C2, and opposite resistance into node voltage by sum of the resistance. It is the formula for the gain, and Vf of S by V naught of S is equals to R2 parallel to XC2 by R1 plus XC1 plus R2 parallel to XC2. R2 by J omega C2 by J omega C2 R2 plus 1 by J omega C2 by R1 plus C1 plus R2 by J omega C2 by J omega C2 R2 plus R2 C2 by J omega C2 is equals to R2 by 1 plus j omega R2 C2 by R1 plus XC1 plus R2 by 1 plus j omega R2 C2. And we consider R1 is equals to R2 is equals to R and C1 is equals to C2 is equals to C. Vf of S is equals to R by 1 plus j omega RC and V naught of S R1 plus 1 by j omega C plus R2 by 1 plus j omega RC is equals to R by 1 plus j omega RC by R1 of j omega C 1 plus j omega RC plus 1 plus j omega RC plus R of j omega C by j omega C 1 plus j omega RC and R by 1 plus j omega RC by R of j omega C 1 plus j omega RC plus 1 plus j omega RC plus RJ by omega C. J omega C into 1 plus j omega RC. R by Rj omega C plus I square omega square R square C square plus 1 plus j omega RC plus j omega RC. And we know that W is equals to 1 by RC by j of omega C and Rj omega RC by j omega RC minus omega square R square C square plus 1 plus j omega RC plus j omega RC. We get JRC by JRC by RC minus 1 by R square C square. R square C square plus 1 plus J by 1 by RC into RC plus J into 1 by RC into RC. And all the R squares, C squares, RCs will be cutted. Then J by J minus 1 plus J plus J is equals to 1 by 3. Vf of S by V naught of S is equals to beta is equals to we got 1 by 3. From Backhausen criterion, A beta is equals to 1. A is equals to 1 by 3 is equals to 1. A is equals to 1 is equals to 3. A equal to 3. Gain impedance is equals to 3.